Okay, so in this video we're going to look at the cartilaginous joints. And remember, we talked about how there are three structural classifications of joints. That we had fibrous, cartilaginous, and synovial. Now for the fibrous joints, we said we had our gomphoses, syndesmoses, and our sutures. But with the cartilaginous joints, they're bones united by cartilage, not fibrous tissue. So like the fibrous joints though, they don't have a joint cavity. So basically you just find cartilage between the two bones. There's no cavity there. And again, these are also not highly movable. Some of these are going to be amphiarthrotic and synarthrotic, but not diarthrotic. So the two types of cartilaginous joints are the synchondroses and the symphyses. A synchondrosis is a joint that's united by hyaline cartilage, and a symphysis is a joint united by fibrocartilage, but we don't have joints that are united by elastic cartilage. So for the synchondrosis, it's a bar or plate of hyaline cartilage that unites those bones or connects them. Almost all of these are synarthrotic. Even though hyaline cartilage is slightly movable and kind of stretchable, technically the place where the two bones meet is going to be synarthrotic. But that doesn't mean the cartilage itself can't expand. It's just that where the cartilage meets the bone, it's not going to move a whole lot. So examples of synchondroses would be like the epiphyseal plates. So remember your growth plate between the epiphysis and diaphysis of your long bones. These are technically a synchondrosis because you have a place where there's epiphyseal cartilage, right? The hyaline cartilage that's separating two bones. So that what's cool then is your epiphyseal plate or growth plate is technically a joint. Now you also find hyaline cartilage comprising the costal cartilages of your ribs. So technically where the rib meets the sternum, that's going to be a synchondrosis, which is a hyaline cartilage joint. So an example of this is like where the first rib meets the manubrium of your sternum. But other ribs as well are going to have hyaline cartilage, except for the floating ribs. They don't have cartilage. So two examples here. Remember we talked about the epiphyseal plate, which is your growth plate. Technically this is a joint because you're separating two bones and they're united by a plate of hyaline cartilage, which makes it a synchondrosis. Now, where the ribs meet the sternum, they're going to be connected by a little bit of hyaline cartilage here. So it's a bar of hyaline cartilage. And so this is also technically a synchondrosis. Now, this makes sense with respect to the thoracic cavity because hyaline cartilage is kind of stretchable. So this is going to allow for some degree of stretch of your thoracic cage during ventilation or breathing. Now, the symphyses are joints that are united by fibrocartilage. We've talked about one symphysis already back in bones, and that was the pubic symphysis, right? And so technically the pubic symphysis is going to be a little bit of fibrocartilage there. Now you might also find some hyaline cartilage comprising the articular surfaces of those bones, but you will find fibrocartilage, in the middle of those joints. Now symphyses are strong because fibrocartilage has lots of collagen fibers. But these are going to be amphiarthrotic and slightly movable. And so it would make sense then to have symphyses at like the pubic symphysis, which unites the two halves of your pelvis, or even the intervertebral joints. That way there's some degree of movability of your spine. So if we look at the symphysis joint of our spine here, we say that in the lumbar region, what separates these two vertebrae then is a plate of fibrocartilage. Now we still have articular cartilage at the ends of these bones, but in the middle of this joint, we find a nice big plate of fibrocartilage, and this allows for a degree of movability here of the spine. So each individual intervertebral joint of your spine can move a little bit, which means that the whole spine can move quite a bit. Now that's an example of a symphysis joint because it's made by fibrocartilage. Now another example of the symphysis is the pubic symphysis here, which unites the two halves of your pelvis. So this is one os coxa, this is another os coxa, and each one's made of three different bones. We have the ilium, the ischium, and the pubis. But each half of the os coxa here, which make up the pelvic girdle, they're united anteriorly by this pubic symphysis. So what's kind of odd here then is right in the anterior part of the pelvic girdle, you find a little bit of fibrocartilage. Now the function of this is to allow for a little bit of wobble of your pelvic girdle. That way when you're walking, it's kind of cushioned, and these are some degree of movability here. That way you don't walk so rigidly. And also this pubic symphysis can relax during labor. That way the two halves of the pelvis can separate, which opens up the pelvic outlet, which makes it easier for birth to occur. In fact, there's a hormone called relaxin that makes this cartilage a little bit weaker, and that way these bones can separate more. Now the joint doesn't break, it's just that this cartilage is a little more loose, so it's more stretchable.